Good afternoon, everybody. I'm sorry I had to cancel the class last week, Thursday. I didn't feel well at all. But today I'm feeling good, I'm feeling well, and we are ready to go. So we are going to start a new lecture here, lecture number 20. Well, lecture 19 is the first section in chapter 10, and it's a brand new one. Well, I don't really feel good about that, just I have to start it this way. On the other hand, all the formulas will be provided. Oh, by the way, you have a book and everything with you, all right? So I don't have to worry about it too much, but still you must know which concept you must apply and what is involved in the formula. Number one is that you have to know your calculator, so how it works, because different brand, just calculators work differently. So you have to find out if there is something that you cannot calculate. That means you must look at the manual and then just Google it and then find out. All right. So last time I put it aside one problem for your homework. Okay. Did you do this? Example 6 in value of Manhattan Island. Yes. Yes, this one is, right now Manhattan Island, that's not a really good place to be in, but otherwise you want to go there one day, right? Unless, just probably many of you have been there, but it's always an exciting place for me. Well, so let's look at the history of Manhattan Island. So in 1626, Peter Minuit purchased Manhattan Island for trinkets and clothes valued at about $24. Well, that was a long time ago. It is a very little amount, but still, that is a long time ago. Exactly how many years ago? Well, we are going to look at the timeline of 2018. Yeah, so it is 392 years ago. 392 years ago, if you look at this from 2018, all right? So, let's think about the value of this Manhattan Island, basically just the heart of New York City, okay? So, imagine if this $24 was in the bank and it grows at following this way, 3.2% and the compounded quarterly until 2018. Another option we want to consider is it grows at 6.4%, okay, but compounded quarterly until 2018. And then we are going to Google the value of Manhattan Island, this real estate value, just land value, I'm sorry, do not think about those buildings. Just the land value of Manhattan Island and compare that which model fits better, okay? So 3.2%, so what do we need to do? What we need over here is, this is R. R is, I'm going to erase this part and then come back, okay? R is 3.2%, which is 0.032. Compounded quarterly, that makes M equals 4, and T is 392 years. So from here, what do we get? The little I is R over M, which is 0.032 over 4, which is 0.008. The what is N? N is T times M, so 392 times 4, which is 1568. 1568. So what is the present value now? So this is $24. Okay, that was a present value. So from here, what is future value for now? Is that correct? Okay. So present value or principal. So future value F equals 1 plus I to the n times P. So 1 plus I is 0.008 to the what power? Huge power, 1568. And then multiply by, yes, 24. How much is that? That is $402,146. Okay, so I'm going to simply say about 6.4 million. $6.4 million. Oh, the whole New York City, so to speak, roughly. Well, no way, right? This model doesn't really fit very well. Okay, now we are going to switch this one to 6.4%. In other words, we just double the interest rate, and the remaining other conditions just the same. All right, so what do you have to do? This one, so B over here is 6.4%. So R is 0.064. Therefore, here is 64. There is 16. Yeah. I becomes 0.016. N is the same. Alright, so what do we have to do? This is 16. Alright, that's the only difference. You will see. Well, only difference, I said, sounds like not a big deal, but look at the answer, if that is a big deal or a small deal. Well, guess what? I got 1.5 times 10 to the 12th power. So look, what is 10 to the 12th power? 10 to the 6 is 1 million. So 10 to the 9th, every third digit, right? So changes the unit. So that is 1 billion. So what's next? That is 10 to the 12th. That is 1 trillion. So in other words, based on this model, the Manhattan land value is approximately $1.5 trillion as of 2018. Now you go to your computer or on your smartphone, go and Google land value of Manhattan Island. Well, I did it myself, and then it gives me, I found the very first one. It says clearly that is about $1.74 trillion as of April 2018. $1.74 trillion in April 2018. Isn't it pretty close? Yeah, very, very close to this model. So imagine this is the land value in 2018, and then if you find just equivalent concept, just saving some money in the bank is like saving $24 under this condition, 6.4% annually but compounded quarterly for 392 years. Yes, you are going to have almost to this value, $1.5 trillion. Okay. So I thought it was very interesting example over here. Okay, and you can really relate it to real world situation over here. Okay, now we go to lecture 20. Lecture 20 is, of course, we are going to use the same, a lot of the same concept. Basically, money grows, okay, based on the interest rate and based on the time you allow in the bank. Well, today the concept is annuities. Okay, so what is annuities? This is lecture 20. An annuity is a series of equal payment made at equal intervals. So for example, so let's say, just make a simple thing, even for just 1 year, but you are going to make a payment at end of each month, okay? Each month. So this is the thing. In the previous concept of compound interest, what you did was just you deposit your principal in the bank and then you wait for the whole year. You don't do anything. You do not withdraw any money from the account, or you do not add any other deposit to your account. Just let it sit and you wait, and then it grows to how much. That was a concept. On the other hand, this time, I'm going to put this word, goes in. That means your money goes into the bank, okay? Each month, therefore 12 times, correct? So each month, so let's say you do like $100. $100, $1,000, the amount doesn't matter, but the amount has to be equal every single time and at the same equal intervals. So each month or each, every 3 months or each quarter or each half year, things like that. Okay, so that is the concept of annuity. Well, in terms of annuity, you can have, the first example was like you deposit 12 times a year. On the other hand, the opposite concept can be also made, which means you are going to put some lump sum in the beginning. Okay? And then from there, you are going to withdraw every time. Okay? Every month. So at the end of the year, so your money is in the bank, the balance is going to be 0. So in other words, you exhaust the fund in the account because you withdraw money every time. So again, you are going to withdraw same amount and at equal intervals. So that means every month or every quarter year, okay, or every half year, things like that. Okay, so 2 different concepts. So future value and present value. Yes, that one is going to be is the difference. So let's look at this example. As a parent of a newborn daughter, you decide to save for her college education by depositing $200 at the end of every month into savings account, paying 2.7% interest compounded monthly. Wow, that was a long sentence. Okay. So you deposit, in other words, you deposit $200. How often? At the end of every month. So I want you to underline this every indicates what? You do it repeatedly, okay? Not just one time. And what is the condition? The bank is going to give you 2.7% interest compounded monthly. Yes, you deposit every month, therefore this time interval for compounding interval has to be the same as your deposit interval, so compounded monthly. Okay? All right. 18 years from now, after you make the last of 216 payments, so that is equal as 18 years. Yes, you enjoy your daughters, growing to elementary school, to high school years, and then finally now your daughter is ready to go to college and you are going to see the bank and then, oh, how much money do I have? Okay? Well, the account will contain, this one example, so just give you the whole thing. So the amount contains $55,549. Every month, $200 for 18 years, money grows to this. So I'm going to use diagram. So you deposit each and every time is $200 for how many times? That is 216 payments. So deposit over here, that is 216 times. As a result, you are going to have a lump sum of $55,549. So this is a simple summary. Okay. Now the new vocabulary over here. You deposit the equal amount. Well, we call this rent. Okay, it's like when you sign the lease for your apartment, you pay the rent every month. So just remember that. Okay. So this is a rent, and this is future value as before. And all these R's and I's, these are the same. So this is R, correct? Okay. And the 18 is T. And now only the new vocabulary over here is rent. Okay. We are going to come back to number 2 later. Okay. So this time, after series of deposit, you are going to have a lump sum amount in the future. So you can call this kind of annuity future value annuity, future value annuity, or look at this your account. Look at your account. The balance is increasing, right? Because you keep depositing $200, so we can say this one increasing value, increasing annuity. Okay, the book is using this term, increasing annuity. And this is a future value, that's a lump sum that you are going to have. Okay, so what is the formula for this? Okay. The formula for this is the future value of your annuity is 1 plus I to the n minus 1 divided by I times R. Very, very complicated. Last time your future value annuity for compounding interest, okay? The compounding interest part was future value is 1 plus I to the n times P. It's pretty simple compared to that. Okay, we thought it was complicated, but compared to today's formula, yes, that was a simple and a nice one. And as you see in the in numerator, this power and then subtract 1. So it is best to start with opening a parenthesis and then subtract 1 and this, close it. Okay? And divide by I and then multiply by rent. Rent is what? $200 in this case. This is a formula, and yeah, example 1, I already did what this IRN was, okay? So let's look at the problem. I'm going to leave this formula. So there are just 2 versions. So one is that F equals 1 plus I to the n minus 1 over I times R, or sometimes you need rent to compute. That is, I just reciprocated, so I over 1 plus I to the n subtract 1 times F, like that. Okay? And I want to emphasize this, I open the parenthesis. So, ready? Okay. Example 2. Mr. Adams would like to buy a $30,000 airplane when he retires in 8 years. So, Mr. Adams needs $30,000 or wants, okay, $30,000 in 8 years for whatever reason, okay? He needs a lump sum of $30,000. So A, how much should he deposit at the end of each half year, okay? Each half year into an account paying 4% interest compounded semi-annually because he deposit money every half a year. Therefore, the bank will compound the interest every half a year. So, is it compounded semi-annually? Semi-annually. Alright, so that he will have enough money to purchase the airplane. So, the amount of deposit. What do we call? Yes, we call this R, rent, and that one is in question mark. Okay, so let's summarize even more over here. Mr. Adams needs $30,000. So in the future, right, in 8 years. So future value F equals 30,000. Time T is 8 years, and what else do you know? M equals what? Twice a year, right? Each half a year, so M equals 2. R equals 4%, so 0.04. Okay, so from here, what can you say? I is 0.04 divided by 2, that is 0.02. Yes. And what is N? In other words, how many times Mr. Adams deposits? Okay? So N equals T times M. That is 8 times 2, so 16 times he is going to deposit. So what is the amount of this deposit? So R equals the second one. So I is 0.02, goes to numerator, and in denominator that is 1 plus. Okay, I'm going to make it double. So 1 plus 0.02 to the n power. N is 16, 16th power, and then subtract 1, and then close the parenthesis, and then times 30,000. So how much is that? Oh, by the way, when you do 1 plus 0.02, you can do this one 1.02 without having any difficulties. So try not to use this parenthesis inside. Okay? Make this use just a parenthesis one time, would be probably better. So that one gives $1,609.50. Okay? So $1,609.50 every half a year into the bank for 8 years, and then Mr. Adams will have $30,000 for his hobby later on. Okay? So let's think about this. I'm going to erase everything. The concept over here is deposit each time. Deposit, deposit. So how many times? 16 times. After he makes the 16th deposit, how much is a lump sum? Lump sum we expect is 30,000.